Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hey, I'm Hannes. I'm a principal consultant for a company called Axxes in Belgium, and I'm joined here today by Marit van Dijk, and we're going to talk about reading code. But first, I'm going to let Marit introduce herself to you.
Thanks, Hannes. Hi, I'm Marit van Dijk. I'm a developer advocate at JetBrains, a Java champion, and I've worked in IT for over 20 years.
So, Marit, talking about reading code, because in university, what they train us to do is write code, and then later in our careers, we spend way more time reading code than we spend writing code. Yet we don't really train for that.
Exactly. So when we learn programming, I learned programming in university, maybe you're learning it now in high school or whatever. We learn to write lots of code. I remember also from my programming classes, we didn't really then look at the solutions on what we could have done better. It was just, does it work? Can you explain how it works? Okay, next assignment. We don't spend time understanding existing code, and then when you're working on an existing code base, obviously you need to understand that code base, or at least a piece of the code base that you're working on. Research has shown that developers spend as much as up to 60% of their time trying to understand existing source code. So that's actually more than we spend on writing code. And there's a Dutch professor, Feline Hermans. She's a professor of computer science education at Vrije Universiteit in Amsterdam. And her research domain is teaching programming. And she did a talk at Strange Loop in 2019, where she talks about how to teach programming. And one of the things that she mentioned in this talk is research from 1992, which is before I learned programming. How about
before I learned programming,
So
definitely.
Before we even learned programming, they did research where they had a classroom who had to learn programming concepts, and they split the classroom into three groups. The first group would write lots of code. I don't even know if I can remember all of the groups. But anyway, some groups would write code, some groups would read code, and some groups would read code with explanations. So with explanations of why certain choices were made or certain implementations were chosen. And what they found was actually that the groups that read the code with annotations, so with explanations about that code, were better able to reproduce the programming concepts than the
even than the group who actually did the programming.
Who did the programming. Even the group that didn't write any code but just read code with explanations did better at reproducing the programming concepts. And that was really interesting because, again, we learn coding by writing lots of code. And actually, after that talk, apparently someone came up to Feline and said, so why don't we practice reading code? And they started an experimental code reading club. And I'm a huge fan of Feline's work. And I
think Feline is fantastic.
Yes. And so we're going to fangirl about Feline a little bit. And so someone came up to her and said, so why don't we practice reading code explicitly? And they started, as an experiment, they started a code reading club. And I read about that somewhere, or I heard about it, and I was like, I want to try that. That sounds super interesting. And I got really lucky because, I have a list of these ideas that I never get to. And I got lucky because a friend reached out and said, we're actually starting a code reading club. Do you want to join? I'm like, yeah, yes. I love it when the universe aligns, right? So we had a code reading club. We've been doing it for about 2 years, but it kind of petered out by now. And our club is different people who have different roles. So developer advocate, developer, testers, quality coaches who live in different countries, who work in different companies, use different programming languages. And we've had that club for once a month, roughly. Not everybody is able to join every time. I travel also for work, so sometimes I'm not there.
You're not at home right now.
Exactly. And it's been really interesting. And what I really, really love about this code reading club is, first of all, like practicing the skill of reading code and feeling like getting better at that and feeling more confident in that. But also I really enjoyed learning what other people notice about a piece of code. Because
different insights.
Yeah, different insights. I just love how other people's brains work, right? So I'm looking at this piece of code, and you scan the code. You don't read code from start to finish. You don't run it from start to finish either. So you kind of scan the code and find the part that you're interested in, and also sort of skip other parts that you think are not relevant to understand what the code is about. And then someone else in the group would get totally fixated on the part that I skipped, and I'm like, that is so interesting. Why? Why do you need to know what that means? Because I don't think it's relevant. And why do I think that it's not relevant? So it gets kind of meta about, how do different people understand code.
But I think part of that is probably because we were never taught to read code. And I think it fits into a bigger beef that I've had with our education for a while now, is we learn a bunch of different skills, but we don't learn how to deal with a normal life-sized project. Like a code base that has been going for a few years, where a lot of the code wasn't written by you, that has developed problems, that has parts of it that aren't documented. And it's a skill we never learn. And I honestly don't understand why, because the first project or the first team you get thrown into after college, you will be faced with all those things.
Exactly,
right?
exactly.
That's what life is. And as a software consultant, that's even more my job than anything else. I need to be up to speed in a new team really quickly, meaning I need to be understanding what you guys have been doing the last couple of years. And usually there is help from people who can explain a thing or two. But you're also left to your own devices quite a lot, looking at the actual code that's there.
But you develop kind of strategies, especially if you do this a lot, right? And I think I find that the code reading exercises can help if you're confronted by a piece of code that is just so complicated. Sometimes you get overwhelmed, I don't even know where to start. In that case, you can take some of the exercises either from the Code Reading Club or from Feline's book. Feline's written a book called The Programmer's Brain, or What Every Programmer Should Know About Cognition. I told you we'd be fangirling about Feline. So she has code reading exercises in that book too that you could apply to your code base. Obviously, working for a tooling company, we build IDEs. Right. There are lots and lots of features in the IDE that can also help you to understand the code.
I definitely want to zoom in on that. But first, before we go there, from the Code Reading Club, what different strategies have you noticed? Because you said you were interested in other people's approaches. What kind of strategies have you seen people apply to understanding new code bases?
So there's a certain set of exercises that we do. And usually we start with an exercise which is called First Glance, which is literally what it is. You take 1 minute, you look at the code, and you find the first thing that you notice, and why is that and realize why is that the first thing that you notice. That already gives you a place to start. And it can be, oh, hey, I recognize this term, so that gives me an idea of what this might be about. Or I have absolutely no idea what this syntax means, and I need to understand that in order to make sense of the code.
Right.
So that will always give you a starting point, even if I'm reading or trying to read JavaScript, which I don't understand, and my brain immediately freezes and is pretty sure I won't be able to figure it out. These code reading exercises can actually help me get past that to the point where I can somewhat make sense of JavaScript some of the time.
I found I've been involved in an audit or two that was for a code base that wasn't in my native programming language. So I'm a native C# speaker.
That's almost like Java.
It's like Microsoft Java, better Java. I mean, we can disagree on the terminology here. But we can't deny that Java and C# have been stealing features of one another for 2 decades
A while.
now. Yeah. So, it's the same thing but different. But
Java currently is looking at other languages as well, like Kotlin and Golang and other things.
But I'm not even that would have been easy, but I've done audits that involved a bunch of PHP as well, and that's a vastly different language. Mm-hmm. If you're proficient at reading code and figuring out where are the pain points, even in a language like PHP, I can figure out some of the things that might be wrong with it and some of the things that they've done well. I mean, not to the same degree of finesse that I could do in C#.
And you might not know all of the gotchas for a particular language.
So you're not familiar with the pitfalls indeed, but you can still figure out like, hey, this part looks really great because you've nicely separated out these concerns and whatever. That part looks like a mess. Can we talk about that? Like, as a conversation starter, definitely possible.
One of my first go-tos is, are there any tests? Otherwise, I have some questions. Yeah, so what I also really like from the Code Reading Club is the different perspectives and the fact that different people notice different things. And it kind of also teaches you empathy in that different people will be working on a code base, and what seems clear to you might not be clear to someone else, which, you know, you might also know from code reviews or whatever.
I think especially in an audit situations, like they bring you in as a consultant to look at basically what's wrong. That's mostly, they never phrase it. They never phrase it like that, but that's the subtext that you get.
How healthy is this code base?
Like basically it means we're stuck. How do we get unstuck? That's basically the question that they ask you. And you walk in and you look at their code, and they're expecting you to basically tear it apart. And if you do that, you're going to get nowhere. Like, you're not going to get any long-term results out of the exercise. So as a consultant, like, I think empathy is very important there.
Yes.
So the first things I always do is point out, like, hey, this part is really well done, and I like that this part of your architecture, how you've tackled this problem. Because if you've written code for a while, you can also spot those things really easily. And it's very easy to glance over that and to focus on this thing that isn't done well and then point that out. And basically what you're doing is you're destroying their life's work, right? I've worked really hard on that.
I know.
And that is not my job, because my job is to help them see where they can improve, but in a way that they will want to improve it.
Yep. And telling them what all is wrong with the code base is maybe not the best way to get them to work on it.
It's the same skill set that you need when you're pairing with a junior dev, when you're doing code reviews for people in your team.
Exactly.
It's like only focusing on the things that need improving, it'll wear out people in no time.
So we still need to be able to talk to people as developers, is what you're saying.
Yeah, we need communication skills.
I know. And so one of the things that because I also do a talk on reading code where I discuss the Code Reading Club and how your IDE can help you make sense of code. I always ask, I say, you look at code that was written by someone else and immediately you hate it because you didn't write it. It's not the way that, or even if you did, if past you wrote it, it's not how you would write it today. You have learned new things. I've actually looked at code that I had written 6 months ago and, learned a lot in those 6 months.
You could do a better job.
Because now I can, we switched from Java to Kotlin, and, Kotlin is fairly easy to get started with if you're coming from Java. It's very similar to get started with, but to make it actually idiomatic might take a while. So that was basically the 6 months. I learned a lot of idiomatic Kotlin. Now I can make this more idiomatic. It's like if you're learning a foreign language, you will put the words in the wrong order and you'll basically be speaking your own language in that other language. And the more fluent you become, the more idiomatic it becomes as well.
I would write Java the way that I write C#, probably.
Probably, yes. At least for starters.
And you would hate it.
We don't hate programming languages.
We just have
might
strong
not
dislikes.
like certain ones, but so, if we're confronted with someone else's code, even past you.
That's proven, psychologically, right?
I don't know about. I don't have a psychology degree, but we see code and we don't like it. But also then I ask, okay, who here in the audience, if I'm doing my talk, who here sets out to write bad code? Sometimes some hands go up. I have to admit, my hand goes up because as a developer advocate, sometimes you have to write the bad code so that you can fix it. That's why I write bad code. No other reason, just saying. Anyway, So nobody sets out to write bad code, but you learn new things, and it might be about the programming language, it might be about architectural patterns, it might be about the domain that you're working on, because we're not all domain experts on the things that we're working on.
It might be because of the constraints that were imposed by the code that was already there, that it was simply not possible to do a clean job on it.
Yeah, or time constraints, or getting stuff out the door quickly.
Somebody once told me that, and I've taken this to heart when I'm doing code reviews, for instance, is I always assume that all the code was written by that person in the time that they had available to them to the best of their ability. Like, I never assume malicious...
Within the constraints, exactly.
Like, I never assume malicious intent. Maybe they didn't have the right skills at the time, and that might have been a skill issue. It might have been that, like, it was delivered under time pressure, or, I mean, there's so many factors that
they might have stuff going on in their personal lives that you don't know about. It could be anything.
It might have even not been that bad of a bit of code. It might just be that because you didn't write it and you don't have the mental model that they were handling at the time that they wrote the code, that is not vibing with you, and it feels like it's bad code, right?
Exactly. It's like, this is not how I would write it, and therefore it is bad. And I think we need to get rid of the and therefore this is bad mindset.
It helps if the person is still there and you can talk to them.
Yeah, and if not, then there's a lot that you can do. I like to do a little bit of Git archaeology sometimes to figure out, hey, this is not the way that I remember it. What happened? And see, what was changed as part of what commit. Maybe get some information from the Git tool window about the commits. Hopefully people write clear commit messages of why something was changed, not what was changed, because we can see that in the diff.
Yeah. And that's a good one. Like, commit messages should always be the why.
Exactly, because, well, there's also a lot of, people love to talk about writing readable code, and there are lots of people who have opinions on that. Coincidentally, Feline's book that I already mentioned, I'm not getting a commission, but you should totally read it, The Programmer's Brain by Feline Hermans.
And you should watch some of her talks.
For sure.
Yeah.
So in her book, she also, because she's a professor, she uses a lot of research on, what makes a good variable name or not, and why. And I really rather like that over lots of opinions that people have on what makes readable code. And I mean, I do believe in naming being as clear as it can possibly be. Of course, naming things is hard. There are two hard problems in computer science: naming things, cache invalidation, and off by one errors. But sometimes there are things that you cannot capture in the code. There might be a business requirement that you can't capture in the naming of your variables or classes or methods or whatever. You might be able to put that in the commit message. You might need to put it somewhere else. You might be able to express it in the names of your tests, for example. But sometimes you can't.
Yeah, and that's where I wanted to circle back to something that you mentioned earlier, where the group that was given context with the code that they were reading, they did the best, right?
Yeah.
And us developers are really good at providing context with the code that we write, because we write lots of comments and documentation and tests, right?
I see where you went with that, yeah. So actually we don't. And even, so one of my most popular social media posts is actually Schrodinger's documentation. If there is documentation, people don't read it. And if there isn't documentation, people complain.
Yes.
So,
but it's like we're terribly, like, even if we do it to the best of our intents, we still suck at it because we don't maintain the documentation.
Yes.
It gets lost.
The further away it is from the code, the harder it is to keep it.
The commit
in
message might refer to a ticket number of a ticketing system you're no longer using. I mean, I've seen all of this happen, right?
Yeah.
Like, it gets lost.
Yeah.
And that brings me back to the thing you mentioned earlier. You said that IDEs can also help us understand code.
Yeah. So in Feline's book, she mentions 3 reasons why code might be confusing. One is a lack of knowledge, one is a lack of information, and one is a lack of processing power in the brain. Obviously, a lack of knowledge, your IDE might not be able to help you with, although you can navigate to, for example, the library that you're using to navigate to the source code and read that and come back. Although that's not necessarily a lack of knowledge. Lack of knowledge you might need to solve by doing some research yourself. possibly outside the IDE. Lack of information, you can navigate to code, but there are also ways that you can pull up information like quick documentation or quick definition to see what the documentation or actual code for a class is without navigating there, because if you keep navigating in a code base, you might end up getting lost. Although there are ways that your IDE can also help you with that if you are familiar with the shortcuts for navigation, or if you're using IntelliJ IDEA, you can use
Rider.
Or Rider, or any of the JetBrains IDEs.
Or even Visual Studio with ReSharper.
That works too.
That works.
I'm more familiar with IntelliJ IDEA as a
Sure.
Java or mostly JVM programmer.
It's very similar.
The brackets in .NET give me eye twitches.
No, we have them the right way around. But
No.
You can be wrong.
But we can we can fight about it. So you can use like a little crosshair symbol to figure out, where actually in my project is this class. So that can be helpful.
Yeah.
So before we started recording, we discussed AI a little bit.
Yeah.
So JetBrains has an AI assistant that is integrated into the IDE. So obviously there's a way to chat with AI assistant, ask it questions. You can ask it questions about your code base. But there are also lots of ways that it's integrated throughout the IDE. So you can use it, for example, to generate commit messages. So no more excuses for bad commit messages. Woohoo! But also one of my
The problem is that the AI won't know the why.
Sometimes it kind of does or kind of guesses at it, and you can still edit the generated commit message. And so it can also help you get over your writer's block if you're like, how would I summarize it? Have AI do it, edit that. That's not how I would write it. I will fix it. There you go. It helps. So one of my favorite features is actually explain this commit to me. So if you want to figure out what happened in this commit, obviously you can look at the diff, but if the diff is very big, AI can kind of summarize what happened there.
Okay.
And I find that helpful to get a start of, what happened in this commit. And then if I need to, I can still look at the diff. But it will give me sort of a summary of what happened.
Gives you context before you dive in.
Yeah, or it can.
Yeah. That's a helpful way to apply AI. So that's a good thing that we have that now.
My favorite features are actually more in the explain this to me than write this code for me. I can write the code myself. That's the part I enjoy. It's the figuring out things that can be hard.
And that I think that we need to focus on that readability in our code base, whichever way we can, whether it is through the help of an IDE or get better at writing readable code or get better at reading code.
Yes, or all of the above. Because,
they're all part of the same problem.
The readability, yes, there's research on, naming your variables this way over that way is better in general.
ABC is not good?
And single letter variables. Anyway, but also it's in the eye of the beholder, and that's one of the things that I really enjoyed about the Code Reading Club is the different perspectives, and something that might be clear to you with your background and experience and knowledge that you have.
And with my frame of reference for that particular code base.
Might not be this as clear for me. If you know how to write a parser, you might be able to read code for a parser. If you don't know how to write a parser, you might not. So there's also the knowledge component. So to circle back to the three things that make code complicated, another thing that might make it complicated is a lack of processing power in the brain. So if there is too much going on because you have nested loops and lots of variables and things to keep track of, then that's where a debugger can, for example, really help. Because it can help you visualize the state of your code and the state of your objects and variables, etc. I really like running stuff through the debugger. Also, my own code, after I've written it, write a test, exercise the test, run it through the debugger, and make sure that what I think happens is actually what happens. Or it can help you figure out bugs. I especially like to write tests to reproduce bugs so that I know that I've understood the bug before I fix it. And also then I have a test to verify that I have fixed it. And that it stays dead. So
I try to define, not for all of the code that I write, but for the domain code. I love expressing certain functionalities as tests first.
Yes.
It's like, hey, I'm going to expect this kind of behavior from my code.
Exactly.
It gives me two things. It gives me documentation about the code that is inevitably going to be there. It also gives me a better understanding of what the code should be doing, and I find that I write cleaner code because of it.
if you think about what the code is supposed to do and you think of examples of what it should do, and if this happens, this should happen. If this doesn't happen, okay, does nothing happen?
Yes.
Does something else happen? Figuring that out beforehand will help you have a clearer picture of what it is that you need to write. So definitely a fan of any type of TDD, where T could also be think first instead of
It's also
just
why I gravitate towards event-driven systems, because I love expressing the functionality inside the domain code as a series of events. If this and this and this has happened, and then I try to do this, the outcome should be this and this. And it reduces the complexity in your tests, because you're always talking about the same thing. It's going to be, I have a series of events, then I queue a command, and I'm expecting these events out of it.
But any type of test will have that same structure, and it helps to think about, given a certain situation, when a thing happens, then this should be the result, and then we have like the BDD or behavior-driven design, given, when, then, which really is the same as the arrange, act, assert from traditional unit tests.
It's always the same thing. I always find that mocking it is way harder than just queuing events and then a command and then seeing events come out once you have that first time infrastructure ready. But it might be a matter of opinion here.
I'm not sure I have a lot of experience in event-driven systems, so I can't really say. But for me, it's thinking about, making it explicit what state you expect the system to be in before you interact with it, how you're going to interact with it, and then what your expected result is. However you call that or structure that, I find that extremely helpful, because, if you have, for example, a bunch of flaky tests, maybe it's because your assumption of the state of that the system will be in is incorrect. And that can be the case, for example, if you have a really large test suite that is all operating on the same environment and might be operating on the same entities in that environment and changing stuff back and forth and interfering with each other. So
running integration tests and then running into race conditions and that sort of stuff.
End-to-end tests where on a test environment where other people are also testing, all of these things. So then you go to being in control of those environments, being in control of that data. Maybe your test sets it up themselves so that each is in control of their own data, so that you know that your given state is in fact what you expect, which will save you lots of...
Are we now advocating for tests as documentation?
Obviously.
Okay.
Is anyone not advocating for tests as documentation?
I'm in your camp.
I wrote an article for 97 Things Every Java Developer Should Know on using tests to write better software. And Kevlin Henney actually quotes some of that article in one of his talks. But basically, make sure that your tests explain the intended behavior of your software, because if they fail, that will help you clarify what you actually expect. That will make it so that you write better code, as we've just discussed. But also that test is there basically like a safety belt, in case you go too fast in the future, it's going to save you, because it's going to fail if you break it. And then, however far in the future that test breaks, you might not remember the exact context or what exactly it was supposed to do. So then you have to analyze that failure and figure out, did I break something that should still work, or did I forget an area of the application where actually this new change also leads to change? And if the name of your test clearly expresses the intended behavior, figuring that out is going to be much, much faster. And I have a few rants on tests, because I've seen a lot of tests. And I've literally worked on a code base where the tests were named test scenario 1, test scenario 2. And when those fail, it's not really clear what needed to happen. So then you have to go read the tests and figure out what they meant. And that adds all of...
But that's reading code again, so...
I would have preferred there to be a name that actually clarifies...
That means something.
Yeah, that means something, because that makes it more readable code, or more easily readable code.
Yes.
So, yeah.
But I think whichever way we look at it, like reading code is a skill that we're all going to have to improve. And we can have IDEs help us, especially with the navigation part and the trying to build that mental model of someone else's code so we don't run into the brain processing power limits. AI can help a little bit as well, but what are the tips that you would give to somebody that is writing code, how they would get better at reading code?
My favorite Sarah Anderson comic is practice. How did you get so good at drawing? Practice. How did you get so good at coding? Practice. How did you get so good at reading code? Practice. So I definitely think that experience helps there, but there are ways that you can deliberately practice reading code, the same way that we practice writing code with code katas or,
or advent of code or...
Exactly, things like that. So you can deliberately practice reading code. You can go to codereading.club, I think is the URL, but we can figure that out for the show notes maybe.
We'll put it in the show notes somewhere.
Yeah. And they occasionally have online events, although they haven't for a while, but they also have resources that you can use. So they have a GitHub repo. We'll put that in the show notes too.
Yeah.
And they have a GitHub repo where they have materials for at least 3 sessions that you can do with a code sample and exercises that you can do and notes for a facilitator so that you can try this out with your team or your colleagues or your software developer friends to practice reading code. If you can't find people to do a session with you, you can use Verline's book and use the exercises from that, apply that to your own code base or your work code base or whatever. And I think that these can help. And obviously, familiarize yourself with the features of your IDE that can help you searching and navigating, testing, running tests, running them through the debugger, ways that you can pull up information like quick documentation, quick reference, type information. Lots of hints also that your IDE can give you, like inlay hints on the types of things. All of these things can be helpful.
We have so many tools available to us. But
not to mention AI assistant and other tools like that,
Great. I already feel like I want to try those tips from the Code Reading Club with some of my team.
Awesome.
But thank you so much. Is there anything you would like to add to the things we talked about?
Read Verline's book.
Read Verline's book, No, so thank you so much for joining me here today and enlightening us about all the things that are reading code.
Thank you. Thanks for having me.
Thanks for listening to this episode of the GoTo podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.